How are you, everybody who is watching this fantastic video? I would like to take this opportunity, firstly, to welcome the local students that I have in this class, and I would like also take this opportunity to welcome all the online communities who will really love electronics engineering, or telecommunication engineering, or computer engineering, or multimedia, just we call it biomedical engineering, so electrical engineering, or computer engineering. My name is Olenjolain. I'm very happy to have you today. And today I'm going to be your teacher to teach you about what I know concerning about analysis of the electronic circuits on the PCB board. So these contents I have prepared this specifically for the beginner students who are in ordinary diploma, let's say NTA level 4. These contents can benefit NTA level 5, NTA level 6, NTA level 7, and even NTA level 8. But these contents also can actually be helpful for secondary students who wishes to be electronics engineer or technician. So I think that you are ready. This is the practical program. I will be just teach you some key concepts theoretically, and then we'll go for the practical purpose. So when you watch this video up to the end, you might see the components or the items that you need in order for you to learn. But the big components that we need, we need two things or two items. One, we need a digital multimeter, and then secondly, we need the PCB boards, which you have to analyze its circuit diagram. So I think that you are ready, and I don't want to waste much of your time. I would like just to appreciate the students who I have locally, and then we go to the blackboards in order to speak the truth about electronics engineering. Okay, how are you, my dear students? Yes. Are you okay? Yes. Are you happy? Do you love electronics engineering? Yes. Okay, so you hear. They love, they are ready, and even for you, online community, you are ready. Let us go to the business. So the module or the course is called the Fundamental of Electronics Engineering. Say Fundamental of Electronics Engineering. In case you have a questions, don't hesitate to stop me, and don't hesitate to ask the questions along the moments, or it means along the lecture or along this workshop. So you should not wait until the end. I will give you a chance to ask questions. But in case you didn't understand or you have a question, raise up your hand for these local students, and also for those online, just use the comment sections to let me know about your challenge, because I love questions more than even teaching. But remember that when I'll be teaching you these concepts, it doesn't mean that I know everything about electronics engineering. That's the warning and that's the cautions that I give all the students. I don't know everything about electronics engineering. I just know a small portion, but I always have a responsibility to teach other students. So the course is called the Fundamental of Electronics Engineering, and this is chapter 3, which we call the Analysis of Electronic Circuit Boards or Electronic Circuits on the PCB boards. Class A, Analysis of Electronic Circuits on the PCB board. And then this is workshop 1. We call it Introductions of Analysis of Electronic Circuits on the PCB board. So listen careful. Let me just do these introductions to build a concept. Before we talk the concepts of analysis, let us talk about the concepts of the design. Because the circuit which will be given on the PCB board before you've been given to analyze, it means it has been designed. So before we analyze, or I teach you some skills that you have to follow, or you have to follow in analysis, let me just introduce to you the concepts of the design. Design, or we call it just the design. So design. Design of what? So design of electronics system. Students, be serious. Have your exercise book and have your fresh mind. So designs of electronic system. So you say that in order to design an electronics system, in order to design an electronic system, system or device, okay, you need to follow the following algorithm. Algorithm, say algorithm. This is the computer terminology, algorithms. Simply, it means that, in other words, it means that you have to follow the following procedures. So before I teach you these procedures that we follow in design, let me remind you, we taught you this concept during your secondary educations in Form 1, especially Form 1, whether in biology. I think that we learned these concepts in biology, physics, and chemistry. 7 steps that you have to follow on solving scientific problem. Are we together? Yes. So recall 7 steps, because this is very important. Steps of solving scientific problem. The first step is what? Identify what? Identify the problem. The second step is what? Hypothesis formulation. Hypothesis what? Formulation. Or formulate the hypothesis. Number 3 is what? Experimentation. Experimentation. Number 4 is what? Data collection. Data collection. Number 5 is what? Data analysis. Welcome. Data what? Analysis. Number 6 is what? Data interpretation. Interpretation. Data what? The 7th step of solving any scientific problem, we call it is what? Conclusion. Why do we remind ourselves about these 7 steps that you have to follow on solving engineering problem? The reasons, or the reason to refer, or just to, the reasons for us to recall these 7 steps is engineering is the purposeful use of what? Of science. So if you wanted to understand and apply engineering in your life, you must firstly understand science. Okay? In other words, we can say that the prerequisite of engineering is science. The prior knowledge that you need to have before you learn engineering is what? Science. So I want to show you the algorithm that we are following in engineering or in electronics engineering on designing is actual a subset of what? A subset, or is actual, it has been developed, or we developed it from the 7 steps of solving a scientific problem. Are we together? So remember this, let me just remind you, not before. Engineering. So number 1, engineering is the purposeful use of what? Of science. So because we are learning electronics engineering, so you say that electronics, if somebody asks you what is electronics engineering? Electronics engineering is a purposeful use of electronics science. So that's why that we have always to remember about science. Okay? You have always to remember about science. Then the third point to note is this one. The prerequisite concepts or prerequisite knowledge and the skills of electronics engineering. Electronics engineering is what? The prerequisite concepts or knowledge and skills of electronics engineering is what? Is electronic science. So the prerequisite of electronics engineering, the prior knowledge that you have to know, is electronics science. Bear that in your mind. So these are the 3 points that always you have to note. So if that's the case now, we say that, let me teach you about algorithm of designing electronics, algorithms of designing electronics, designing electronics system, electronic systems or devices. So again, in this world we have different problems. Not all the problems that we have in our society are engineering problems or needs an engineering solution. So the first step or the first procedure, you have to identify what? Engineering problem. So it's just like the first step on solving a scientific problem. On solving what? A scientific problem. So the first step, we say that identify what? Engineering what? Because for instance, let's say for me, I might have, maybe I don't have money today. Is that the engineering problem? No, that's the financial problem. Possibly that maybe we have a student in this class whose name is Brighton. He was sick last week. Is that the engineering problem? No, that's the biological problem. That's the health problem. So when you say that identify problems, you should not be general. You have to specify yourself. Because we have engineering problems and also we have scientific problems. We have mathematics. Oh, so I remember something here. So in this, the prerequisite skills, I remembered something. I just wanted to forget. Very important concept. So he said the prerequisite concept or knowledge and skills or fault of electronics engineering is electronic science and applied mathematics. I forgot mathematics there. The queen of engineering. And also for this sentence, we say electronics engineering is the purpose use of electronics science. So these are the prerequisite concepts. That's why in secondary education we taught you science subjects, business subjects, artist subjects, and the mathematics. So the aim, if you will be measured in engineering, you have to use the scales. For instance, we taught you how to add numbers in mathematics, right? Yes, so in case of electronics, in case you have maybe you have resistor 1, resistor 2, and resistor 3 connected in series, then you have to add the year to find the equivalence resistance. You have to add the individual resistance. Are we together? Yeah, so let us continue to algorithms. Say algorithms of designing electronic system or devices. So the first step is identify what? Engineering problem. Then the second step, we say that you have to propose the solution. Propose the electronics, let's say that propose electronics engineering solution. Propose the engineering, propose the electronics engineering solution for that particular problems which you have identified. So the proposal, you might propose even more than one electronics engineering solution, right? You should not worry. But if you propose, for instance, three solutions for that particular problems, then you can choose or you can arrange. It means you can, just to say that you can arrange or you can arrange the three solutions and you might pick one to test it if it can fit or it can solve the problem. Are we together? Yeah, so this one is we call it propose the electronics engineering. It might be solution or solutions. Okay, so usually once you propose the electronics engineering solution, You might go to another part, which is not simple. For the beginners, we don't actually advise them to go through, because sometimes they might give up to say that all the electronics problems have been solved. Have been what? Have been solved. While it's not true. So the third step, for this case, we call it methodology. But in case of methodologies, the first, I think, let me just take you, literature what? Literature review. Literature review. Literature what? Review. Say literature review. So literature review, actually, you'll focus about that, about what? Means review the previous proposed solution. Previous proposed solution about what? Previous proposed solution about the problem. So literature review, is said a review the proposed the previous. Yes. Previous what? Proposed the other proposed solution. Previous or review other proposed solution about what? The problem. For the beginner, we don't ask them or we don't encourage them to do literature review. Why? Because when you do literature review, for instance, how you can design or you can solve maybe fire breakout in a particular place. You might find that there are a number of solutions which have been designed and implemented, maybe even 20. So then, for instance, yourself will propose just one solution. And then, when you'll be doing literature review, you might find another engineer or technician who has already implemented the solutions that you are proposing, and each and everything you are thinking about, it's the same. So from there, you can give up that to say, I have nothing to contribute. So we don't entertain beginner students to go for the literature review. We entertain you once you get the skills. Then from there, first of all, you have to find a category that are the problems that I can solve. Or let's say these are the problems which are existing. Let me try to solve it. Okay? Regardless that somebody has solved it or nobody has solved it. So this we call it literature review. So then, after this one, number 4, the first step, we say that now we are going to discuss about the diagrams. So you have to represent your solution on the general block what class? Block what? Block diagram. General, say general block diagram. So in general block diagrams, in most cases, you are going to use rectangles and what? And the arrows. Rectangles and the arrows. That the first step. So the general block diagrams actually will represent the big picture of your proposed solution in terms of what? Diagram. Are we together? Yes. So the next step, which will be number 5, once you have the general block diagram, you can go or you can draw another block diagram, which you call it detailed block diagram. Say detailed block diagram. Say detailed block diagram. Also here we are using rectangles and what? And arrows. Are we together? So once you have developed your detailed block diagram, then you come for the next step, which is number 6. Then now, this is the point where that you have to do something we call in engineering design. Or for the technician, we just tell them it's a time now to do implementation. Because for the technicians, in most cases, their main responsibility is to implement. So for the technician, they might even ignore how the circuit is being designed. So this is the schematic circuit corresponding to the general block diagram, corresponding to the detailed block diagram, corresponding to my proposed solution. So then I have to implement it by using electronics components. Are we together? But the main responsibility of engineer is actually to design system. So when you say designing, it means that it's a matter of computation, right? Computations and reviewing the formulas that we've been learning about a particular part of that system. So here we have design and implementation. Once we do the electronics designs and implementation of electronics, it means that once we do the design, it means that in this process of design or implementation, we open each block of the detailed block diagram. We open. So once we open, we have to come up with with the electronics components or electronics modules, right? Or maybe some electronics we call headers, or some electronics connectors. So those are the parts that we're expecting to have. Farid, take care about your eyes. So then once we do design, we come up with the schematic circuit diagram. So the schematic circuit diagram, we are using electronics schematic symbols. Electronic schematic symbols. We are using electronic schematic symbols. So that's the process that we are going to do. So we are using, or we come up with a schematic circuit diagram. You might have more than one schematic circuit diagram. For instance, if you have a transmitter unit and receiver unit, you might have a schematic circuit diagram for transmitter and a schematic circuit diagram for receiver. Are we together? Are we together? Then once we have our schematic circuit diagram, then that's the good news. Now we have something in our hands that we can simulate. We can test it by using the computer simulation software. Okay? So the next step of our design is what? Is simulation. The next step is what? Class is what? Simulation. So the process of simulation will be using what? Computer software. Electronics computer what? Software. But if you will end on the block diagram, you will have nothing to simulate. Right? If you will end in detailed block diagram, you will have nothing to simulate. If you will end on the proposed electronics engineering solution, you will have nothing to simulate. Class or students, do you have any questions up to that moment? If you have any question, please let me know. Do you have any question? No. Okay. So this is step number 7. Step number 7 is what? Simulation, where we have online and offline electronic simulation what? Software. Then we go for the step number 8. What do you think about the step number 8? So now when we simulate our schematic circuit diagram and we get the results, we can have also another part which is very important. Let me just say, open your mind. So here we expect you to have what? Table or simulation results. Simulation what? Results. Because these algorithms actual will trigger your mind to know about the steps. You should not just rush to the hardware implementation while even in the software the system does not work. Are we together? So we need simulation what? Say simulation results. So you should use the electronic simulation software which actually can give you results. And do you remember the results? The results can be represented by using table, and also some of the results might be graphs. And in order to have results, you should know how to do measurements. Are we together? Okay. Then the next step, after having simulation results, we have simulation results, and these simulation results are represented by using what? Tables and the graphs. So if you are designing or you are implementing a particular electronic system or telecommunication system or computer system or maybe electrical system or biomedical system, and then you don't have simulation results, actually we are doing nothing. Are we together? Because some of the system of devices, or just we say that in present and future technology, there is no any way out that you can design, or you can design whether a complicated or a simple electronic device, or simple electronic machine, or complicated electronic device or system without passing through the simulation process. Are we together? Class, are we together? Are we together? Okay. So simulation what? Results. Then the next step, we go for the hardware. Say hardware. Say hardware. Hardware what? Implementation. Hardware implementation. So in the hardware implementation, what do you say? So in hardware, say hardware implementation. Okay, you may implement your circuit on the breadboard. These are the implementing boards. You may implement your circuit on the Vero board. You may implement your circuit on the PCB board. Those we call them hardware implementation environment. So once we have hardware implementation, we come up. I know that some students have taught them the algorithms of what? Of design. But by that time, I just skip these some steps. Right? Yes, I think that I have taught you only 7 steps, something like that. 7 or something like that. But I did not include simulation results. And I did not include the next step. Why? Because I was introducing to you by that time. So because you have the introduction, now I have to add the value on top of what you know. Okay? So this simulation result, sometimes in some of the books you can call it testing. Testing of what? Of testing of the circuit. So the step number 10, once you have hardware, we say that we can have testing. We can have what? Testing, or we can call it hardware testing and result. Testing and what? And the results. But the hardware results, just you can say that the results, but where? On the hardware implementation. Hardware implementation environment. Hardware implementation what? Environment. So you can have a testing and what? Results. It's just the hardware results. And these hardware results should be represented in terms of what? Tables and what? Graphs. That's why I gave you that we can summarize engineering in 5 terminologies. Number 1 is what? Engineering is all about what? Numbers. Engineering is all about what? Formula and the equations. Engineering is all about what? Diagrams. You see the block diagrams, the schematic circuit diagram, the PCB layout diagram. And engineering is all about what? Tables. To be table of results. Then lastly, engineering is all about what? Graphs. So you should love tables, you should love diagrams, you should love graphs, even if that they are difficult for you to find them. But you should love them. Okay? Yes, Ka? Okay, fine. So tables and what? And graphs. So then, once you have testing and results, the last step, which is also corresponding to what we have, but we say that this testing and results, we can have that this is the prototype testing, hardware implementation or implementation of the prototypes. Sometimes this testing or from what hardware implementation, we might call it a prototype, not a product, not a final product. Prototype. Say prototype. Say prototype. So I think that, yes, prototype. And also when you say the testing of what? Of prototype. So when you say prototype, we mean that testing of prototype. So here, hardware implementation or prototype implementation. That's the meaning, right? Why? What the meaning is, what the difference between prototype, say prototype. In engineering, we have prototype and we have final product. Say prototype and final product. So prototype, it's This we call it's a device or a system which is used in the process of designing and testing before duplicating. Right? So it means that the prototypes, the companies or the industries can invest a lot of money on designing and testing the prototypes before the final product. Are we together? We are not together. Let me just use this simple language for you to tell you. Let me go to the Word of God, that is actually the Holy Bible. Right? Even in most of the books, even in Qurans and other books that also explain. God has created a man whose name is called who? Adam. Are we together? And then in the second chapter of Genesis, God has created a woman whose name is what? Eve. Which in Swahili we call it Eva, right? Or Hawa. Okay? Then, so it means Adam and Hawa are God's prototype. What does it mean? It means God took Adam and Hawa, put them in the Garden of Eden to test them, to see how faithful they are, to see how they can relate with God. Are we together? Afterward, Adam and Eve have been confirmed that this is God's image and likeness. So then what, you know what God has done? Actually, he went inside Adam and Eve, then they reproduced these 60 billions, more than 60 billion mankind in this world. Have you understood? So we are the final product, but Adam and Eve were what? God's prototype. And you know what happens to them? They failed as a prototype. Are we together? Are we together? Do you remember that Adam has been created from the soil? How about you? Are you created from the soil? Your father and mother went and take the soil and create you? No. Are we together? Are we together? So similarly, the process, I used to tell you that actually everything about innovations is just a copy of what God has done. Are we together? Actually, what God has done, for instance, let's say video camera. So video camera is actually representing the human eye, which God has created. Simple like that. So the designer or the innovators of video cameras, actually they studied the human eye. How does it function? How does it localize itself? How does it send the signal to the brain? That's all. Are we together, class? For instance, this mobile phone, this is my mobile phone. This is not a prototype anymore. It's Techno Camon 11 Pro, right? So this is what a final product of Techno company. But before making Techno Camon 11 Pro, there is one mobile phone which there's one Techno Camon 11 Pro mobile phone prototype, which has been used in the process of designing, testing, actually throwing downs, trying to use the fingerprint, trying to use the camera, how does it take photos, and if something is wrong, the engineers go back for the design. Are we together? So prototypes is just for the purpose of testing and actual appreciating what you are thinking. Okay? So in electronics engineering, so in electronics industries, we have prototype and final product. So the final product now, you can send it to solve a problem. But the prototypes is just for the matter of you to collect data, to see whether your system is convenient with the problems that you are going to solve with the environments, and to study and study and study and study. Are we together? Are we together? For instance, my mobile phones, if you read the data sheet, it means that they told me it can make a call, right? So this one, I didn't buy it in order to test whether it can make a call. There is a prototype which it has been tested that I can talk and the microphone can pick out the voice signal. Class, are we together? Are we together? So then, after hardware or prototype implementation, or after testing and results, or testing of the prototypes and results, the next step now, we have to go to the next, to the last step, which you call it's the last step in solving, in 7 steps of solving a scientific problem. So you draw the conclusion, whether your proposed solutions solved the problem or it did not solve. Are we together? Are we together? So if the conclusion that the proposed solution solved the problem, we go the next step of making the final product. And the final product is just the duplicate of the prototype. Are we together? So that's why that you can send for the mass production. Class, are we together? Are we together? Are we together? So number 12. So the next step here, we say that the final product. So manufacturing of manufacturing of final product. Pardon? Number what? Number 12. If actually that your proposed solutions did not solve the problem, you have to go back and redesign or do some adjustment. So once you are satisfied with the performance of the prototype, you can go for the final product. Final electronics product. I heard that you are talking. What are you saying? Manufacturing of final electronics product. Class, are we together? Yes. So if that's clear, now let us go to the second concept of analysis. Are we together? Because the theme of this subject is analysis of electronic circuits on the PCB board. Okay. Are you ready for that? Okay. So number 2. That was number 1. Analysis of analysis of electronics system or device on PCB board. So why did I teach you about design of electronic system? The reason is the design sequence or algorithms is a prerequisite of analysis. You can call it analysis or study. Analysis is actually that is study. You should not confuse the concepts of analysis of electronic system or device with the step number 5 of solving a scientific problems, which is called data analysis. Don't confuse that. But the simple concept here, listen. Analysis of electronic system or device on the PCB boards means that you have the final prototype or the final product. So you have to revise to go back to the problems which had been solved. Are we together? So analysis of electronic system or device, it's a reverse process of design. Are we together? Are we together? Are we together? For those who have learned the concepts of integrations or calculus in mathematics, we used to differentiate a function to find the gradients or the slope, right? And then once you have the slope, whether it's first derivative or second derivative or third derivative, because we say that electronics engineering is is the pursuit of science. The prerequisite of electronics engineering is electronic science and applied mathematics. That's why I mentioned mathematics. So actually, before even explaining in detail, the relationship between design of electronic system or device and the analysis of electronic system and device is actually simple. It's just like the process of differentiation. Because in differentiation, we just have a function, and here we just have its derivative. Actually, this we call is a process of just like differentiation in mathematics. So when you differentiate the function, you get the gradients. And then so we say that integration. So in mathematics, we say that actually this is derivative of the function, ddx of the function, let's say ffx. And then this is the actual the reverse process. If you want to reverse, then it's similar to interval. So what does it mean? If you've been given a function If you differentiate, you find the slope, right? But if you've been given a slope, if you need to get the function, you have to integrate. Are we together? Are we together, Jackie? Yes. So actually, it means that, for instance, if just you want to get the image and relationship of mathematics and electronics, we just say that the problem we want to solve is just a function f of x. Right? The final PCB boards is just the derivative or the slope of the function. To move from, for those who did not, if you don't know anything about calculus, don't worry. I will use another language to explain to you. Okay? For those who are not familiar, because I know in my class some of the students are not familiar with calculus. So this is what? Function. Say function. And this is what? Slope or what? Gradient. So this is representing what? Problem. You see Brighton, what he's doing? And this is representing what? The solution or the circuit on the PCB board. The final prototype. So final products representing the motherboard, right? So if you want to move from problem to the PCB boards, to the final products or final prototypes, we have to do what? Design. If you wanted to move back from the PCB boards to the problems, we have to do what? Analysis. It's just like if you want to change, we want to find the gradient from the function, we have to use what? Differentiation. Right? If you want to get the previous function will be given slope or gradients, we have to use what? Integration. So actual design of electronic system or device is a reverse process of what? Analysis of electronic systems or device on the PCB board. Are we together? Are we together? Okay. That is a simple way that I can talk with mathematicians. Let me talk with those who don't have any idea about integrations and what, or any ideas about calculus. We say that the simple example here is the simple example. For instance, I wanted a mobile phones that can help me to communicate with my parents. Okay? So it means the problem is communication. Yes, I need communication with my parents through voice. Okay? Then the process is, so the problem is what? Communication. Then I have to use design until I come up with a mobile phone that can make a call. Are we together? So this process from problem, voice or communication problems, we call it what? Design. We call it what? We call it what? Design. Are we together? Then if I have a mobile phone, then somebody asks you a question. Why we have mobile phone? Okay? So you can answer that question whether by stating the problems which has been solved by what? By the mobile phone. Right? But now, for you as a technician, Mr. Issa, his mobile phone is not working, maybe in the part of the microphone. And then it has been submitted, or it has been brought, or it has been sent, or it has been brought in your technical center. So then from there, you have to restudy the mobile phones in a reverse process. Because the mobile phones consist differently electronic system and communication system. But the problems is actually in the micro, maybe in voice communication. Are we together? Are we together? So from there, you have to study and you have to go back. You have to move from the mobile phone, which is the final product, towards the what? Towards the problems which have been solved. Are we together? Okay, thank you. So design of electronic system or device on the PCB board is the reverse process of analysis of electronic system or device. So it means that these are the reference process. So we say that simply, let's just write short notes. Analysis of electronics, electronic system, analysis of electronic system or device, okay, on the PCB board is the reverse. So it's the reverse process. Is the reverse process of 40. So this is called the reverse process of 40 of designing what? Electronics system or what? Electronic system or device. So you say it's the reverse, say reverse. Say reverse. Say reverse. So it's the reverse what? Process. That's the simple piece of information that you need to have. Okay? So if it's a reverse process, but also remember that analysis of electronic circuits or system on the PCB board is actual, it's a sequence of steps. Right? It's a sequence of 40 of steps. So if that's the case, let me narrow, because we say that this module, this course is what is more practical. Algorithm of 40 of analysis of electronics circuit. So we said algorithms of analysis of electronic circuit or system on PCB board. On PCB board. So what are the steps that you have to follow? Are we together? Are we together? So the steps that you have to follow, the first step. The first step, we say that we should start from what? From the PCB or PCB board or Vero board of the prototype or final product. So the first thing that we should have the PCB or Vero board of the prototype or final product. That's the first step. Are we together? Why? Because we should not start from the conclusion. Okay, actually, we have to start from here. Because your responsibility is not to test it. Your responsibility is actually to go back and find the problem which has been solved. Are we together? Yes. So this is the first step. It means that the first step you should have, it means that if the electronic systems or device, it has a housing, say housing, you have to take out, you have to open the housing. Can I have one of the prototype? For instance, this is a prototype, but if it's working, we call it it's a what? It's a final product. Are we together? So for instance, that you've been given, this is the kinds of the enclosed prototype. So within this box, we have what? PCB board. So first of all, you should get an access of the PCB board, right? Mainly we have two types of PCB board. We have double-sided and single-sided. So for instance, for this PCB board, this is single-sided. Why it is single-sided? Electronic components are on the top on one side, and the roots and the soldering pads are on the other side. Good luck, you are good luck. That is good luck. Are we together? So you should have the PCB or Vero board. Isa, do you have your Vero board? Okay. So this is the PCB board for those online students. And this is the soldering and the copper roots. On this side, we have what? Electronic component. So this is the first thing that we need, and it's the first process that we have to start with. Are we together? So we don't have any idea about any components within this PCB board. We have to study each component. And then so you have to come up to understand and use the skills and knowledge that we have in electronics to try to predict the problem and the proposed solutions of the designer. So you just have been given a prototype like this one. There is no any data sheet, there's no any user manual, you don't have any idea. Or maybe it has some problems. And then you are technical personnel, you have been consulted. How are you going to solve the problem? Are we together? When you say VeroBot, this is the VeroBot. Class A VeroBot. So this is the VeroBot, because I've mentioned here breadboards, you know it, VeroBot and PCB board. So these VeroBots actually has holes in a particular patterns. So in order to mount electronics components, you have to solder them. Okay? So you may have a circuit on this VeroBot, or you may have a circuit on the PCB board. VeroBots also, it has two sides. It has a top side, this one, this is the top side, and also it has a bottom side. So the bottom side, it's a one that contains copper holes, or copper, the copper surrounding the holes, right? And then the top side is just the plastic. Similarly to this one, this is the bottom part. It contains what the copper material before doing etching process. And this is the top side, which is plastic. Class, are we together? Okay. So, if that the case, we go for the next step. If you have any question, don't hesitate to ask. If you have any question relating about what we have covered today, because if I say that if you have any question, a student might ask you a question which is not relating about what we are covering today. If you have any question related about what we are covering today, you may raise up your hand and ask it. Now, do you have a question? Do you have any doubt? Huh? I think that in part of conclusion or whatever, you had something like a doubt. Or you'll check me in inbox. Okay, so now we have our PCB board. You have our PCB what? Okay, so the second step now, we need a device found in digital multimeter that we call the continuity tester or continuity check. Continuity tester or continuity test. Maraba. Karibu wasalimia. Okay, so the second item that you need is called the continuity tester. Continuity tester or continuity check instrument. So the function of this continuity tester or continuity check, this is the instrument which can help you to start what? To start each point of what? Of electronic circuits on what? PCB board. Can I have the yellow digital multimeter? Can I have it? Can I have the yellow digital multimeter? My yellow digital multimeter. So this is the digital multimeter which contains more than 7 measuring instruments and testing instruments. So for instance that, to say to have a continuity tester, this is continuity tester and diode tester. The default testing instrument, it is diode tester. So once I press the selector button, I have continuity tester. So if there is a continuity between 2 points, then you hear what? A beep and display a resistance less than 50 ohm. So that's the beep. Are we together? If there is no any continuity, you won't hear any beep, and also the resistance will be higher than 50 ohm. Are we together? Yes, so simply you need the continuity tester, and there is no any particular instrument that called continuity tester. Continuity tester, it's a one of the testing instruments built within what? Manual or auto range digital multimeter. Are we together? Are we together? But also if most of the electronic circuits consist of resistors, right? Consist what? So when you draw your schematic circuit diagrams, you also need your ohmmeter to do measurement or to measure resistance of who? Of those resistors found within your electronic circuit. Are we together? Are we together? Yes. So once you have a continuity tester or continuity check, we may use this testing instrument to study the circuit built within the variable or PCB board. Right? And then you know what are we going to have as the results? So we have number 3. We are going to come up with what we call it a rough schematic. Rough schematic circuit diagram. Rough schematic what? Rough schematic circuit diagrams of that particular system. So you'll be using the continuity tester and skills of arranging the components and skills of restudying the circuit, where the input, where the power supply, where the output, where the control unit, where the communication unit. So you should have that skills also. That's why we say that you have to use skills and knowledge of what? Electronics. Are we together? Are we together? So you'll come up with rough schematic circuit what? Diagrams drawn either on paper, mostly drawing on paper. So it means that it's drawn on paper. Then we go for the first step. The first step, now we have what? Rough schematic circuit diagram. Say rough schematic circuit diagram. Then now we can use that rough schematic circuit diagrams, because when you say rough, sometimes you might find that always the input is on the left hand side. But according to you are doing the rough work, you might find that even the input or the sensor or the input unit you may place on the top of the schematic circuit diagram. So when you come up with a clear, now you have to think and rearrange electronics components in a systematic order, in such a way that if other technicians or engineers restudy your schematic diagrams, could understand and could even break down into the big picture. Are we together? Are we together? So then once you have that rough schematic circuit diagrams, you have to come up with what? Clear schematic circuit diagram. So it's all about diagrams. Then once you have that, the next step, which is number 5, once you have a clear schematic circuit diagram, you have to do also, we have to go to the number 5. And number 5 is actual that we have to do or to measure, to identify values of some electronic components. Because you cannot simulate a schematic circuit diagram which does not have values of electronic components. For instance, you cannot go to the schematic editor of a simulation software and then you say that I want to pick a resistor. The software will ask you a resistor of how much resistance. Are we together? Are we together? So you say that measure, identify, it means you can use color code in case of resistor, or measure the values of the discrete electronics components. So identify or measure the values of what? Discrete electronic class electronic components. Example what? Resistor. Identify resistance of what? Of resistor. But I think this is step number 6. Excuse me. This is step number 6. Number 5 is this one. Say that provide the number in ascending order the same, okay, to the multiple electronics components. Multiple electronics shorty, provide the number in ascending order to the multiple electronic shorty, multiple or to the similar electronic shorty, electronic shorty. Example, if you have 3 resistors, one of the resistors just call any, just call R1. It's not a formula that maybe the first or the second, or no, any. So, for instance, if you've been given the same PCB schematic as the same circuit, if the same circuit has been given to 3 or 4 students, the numbering process might differ. Are we together? So, for instance, if within the circuit we have 3 resistors, so you can have R1, R2, R3, etc., etc. Or we can have what? If in case of capacitor, we can have capacitor 1, capacitor 2, capacitor 3, etc., etc. If it's the matter of the diode, you can have diode 1, diode 2, diode 3, etc., etc. If we have LED, we can have LED 1, we can have LED 2, we can have LED 3, etc., etc., etc. Are we together? Are we together? Yes. So then the next step, we say that, the next step, this is number 6, very important. We say that ignore the, okay, we just have. Number 6, you say what? Number 6, what? Measure or identify what? Identify or measure the values of 40 different discrete electronics components. Electronics components found on the given PCB board. Found on the given PCB board. What does it mean? Stop writing. Stop writing. Listen and watch. For instance, if you have example, if you have resistance 1, then we can say resistance 1 is 220 ohm. Are we together? Are we together? Yes. If also we have resistance 3, resistance 2 on that schematic circuit, it's 1 kilo ohm. After measurements, we find that it's 1 what? Kilo ohm. If also you have another resistor, resistance 3, maybe it can be that this is, let's say it is 5 or it is 10. 10 what? Kilo ohm. So once you have these values, you can go to the step of 40, simulating. Are we together? Are we together? Are we together? Okay. So that is step number 6. So step number 7, you may go for the simulation. Say simulation. Simulation of the clear schematic circuit diagram. We see its values. Circuit diagram. We see its values. Then the next process, students, are we together? Is it clear? If you skip any step, you will find the challenges, especially in simulation. Okay? Then we go for the 8th step. Once you do the simulations of the clear schematic, of that schematic circuit diagram, you may do, results are not important because you have the prototypes. You can just check the results, but it's not a great deal. Then you can even skip simulation. Okay? Because your aim is actually want to identify, to know the problem solved by the device or the system. Are we together? So remember, a simulation of the schematic circuit diagram, this we call it in engineering, it's optional. You may skip it. Are we together? So the next step, which is step number 8, we say that now draw the detailed block diagram. Block what? A diagram. How can you draw this detailed block diagram? You stop writing. We used to draw the schematic circuit diagram from the detailed block diagram, right? Here we have a detailed block diagram of particular system. If you want to draw the schematic circuit diagram, we have to open each block and come up with the electronics component. So now, to draw the detailed block diagrams, we draw the detailed block diagrams from what? The clear schematic circuit diagram. How do we draw? So now you have to group the electronic components to become single block. Are we together? Are we together? Kamanzi, you are doing something. I saw it. Okay. So we draw the detailed block diagrams from what? Clear schematic circuit. So remember, block diagrams is just what? Interconnection between what? Different blocks by using what? Arrow. Then the next step, number what? Number 9. Once you have a detailed block diagram, what can we draw from the detailed block diagram? General block diagram. Very interesting. Is electronics beautiful to you? Ask your neighbor. Draw the general block diagram. Draw the general block what? Diagram. If you have any question, don't hesitate. Draw the general block what? General block what? Diagram of what? Of the system. Then number what class? Number 10. So number 10, once you have a general block diagram, we can predict, say predict. Predict what? The proposed solution. Right? Why do you say that you can predict? Because here there is no any particular formula. Because you can present the solutions by using different arrangements of the weights, which might differ from another person. Are we together? Are we together? Yes. So, but your prediction might be true, and your prediction should be relating with the problems, with the solution that you have. Predict what? Predict the what? The previous, proposed what? Proposed the electronics, you forgot electronics. Electronics, engineering what? Solution. Predict the previous proposed. Proposed electronics, engineering what? Engineering what? Solution. Then we go for the step number 11. Step number 11 is what? Predict what? Predict or identify what? Identify electronics what? Engineering what? Engineering problem that has been solved. Then the last step is what, class? The last step, you can have your conclusion. Conclusion. So in case of conclusion, you can just conclusion. In conclusion, you can provide recommendation. Say recommendation. So you can provide recommendation. You might say that maybe the designer has intentions to design this system, but the final products or the final prototypes, it does not solve the problem because of this and this and this and that. Are we together? Is it clear? Did you enjoy? Have you understood? Okay, so if that's the case, now I would like to say that the next step is workshop number 2, where we are going to put in practice all the 11 or all the 12 steps. So we have, so this is the mind, say mind, because this is what always I believe, and this is my policy, mind and duty. This is all about my electronics and telecommunication engineering. Mind and hands. Mind has to work and hands has to what? Are we together? So we are done with the part of what? Mind. The next workshop will be what? Hand. Very interesting. That is my motto, my own motto that I live every day. Class, is it clear? Do you have any question before we wind up our today's workshop? Do you have any question about what we have covered? Everything is clear and well understood. Isn't it? But in case you have any question, don't hesitate to ask. But remember, the simulations is optional. It's not compulsory. But for you who is a beginner, so listen, my advice, during my hands or during my practical, I might skip the simulation part because of maybe the time. I might skip the simulation part, but for you, you have to include in order to practice. That sometimes you might take maybe a prototype like this one on the breadboards. You can also think back and go to back to the simulation without having any information from the manufacturer. Are we together? Are we together? Are we together? So if that's the case, I would like to say that this is the end of our today's workshop. And firstly, I thank God who have taught me about what I've taught you. It's my first time to teach you this concept, especially the second part, how you can analyze the electronic circuits or system on the PCB board. It's my first time, and you are my first prototype. Are you my first prototype or final product? I'm not sure, but you are my first prototype about this one. About designing, I have taught some students previous. But about analysis, you have just got a chance of having this brand new solution. And I want to tell you that there's no any book, there's no any single book that maybe give you all of those steps. For me, I just collected them for almost 7 to 8 years by reading different articles and different sources, but also by putting my hands on practice. Are we together? So for the online community, this is the end of workshop 1. We will ask you that to click the buttons written subscribe for you to be registered in our official YouTube channel, where we use always to contribute the concepts and skills, the knowledge about electronics engineering. So if that's the case, but also I want to ask you, share this content with other Tanzanian students, because this is the time for the moments where we have to enjoy and practice about electronics engineering and telecommunication engineering. If that's the case, I would like to welcome you in the next workshop. Join me when we are going to put our hands, so you'll have a PCB board, and then redesign or analyze that system until we have a proposed problem, or at least we have what predicted problem solving. So thank you very much for your time. May God bless you and keep you until we meet in the next moment.